Saxon's Trig, lesson 81 on page 489 is about law of cosines. So in an earlier lesson, we did law of sines, and I told you that there was another method when you did not have an opposite set that worked, and that is what law of cosines is about. Now they give you three different formulas, and I say rather than memorizing three formulas, if you understand the pattern, you're going to be fine. But before I get into that, it reminds you at the beginning of the lesson that every triangle has three sides and three angles for a total of 6 parts. If we know one side and two other parts, we can solve for the value of the missing parts. If the triangle is a right triangle, the unknown parts can be found by using sine, cosine, or tangent. If the triangle is not a right triangle, and we have the value of a pair, an angle, and its side opposite, you can use law of sines. And if the triangle is not a right triangle and the values of the pairs are not known, then you use law of cosines. And so there's just a more wordy way to say what I said at the beginning. But I wanted to make sure that you didn't miss the three distinctions of the ways to solve. So in the triangle, if you want to solve for the side of A, the formula is going to be A squared equals, this is going to look a lot like Pythagorean theorem, B squared plus C squared minus 2, and the multiplication of whatever you just had here, B and C, with then multiplying with the cosine of the degree opposite the side you're talking about, so cosine A. So the pattern would work the same if you did B squared equals A squared plus C squared minus 2, AC, multiplying here with the cosine of B. So you get the idea that they have three different formulas for solving this, but if you understand the pattern, that's your law of cosine. So in example 1, they give us a triangle. This is y 36 degrees, m 10, x and 7. So I have a y and a 10, a 36 and an x, a 7 and an m. I do not have a set where I know the opposite pair of two different numbers. So we're going to have to do law of cosines. It does not matter which one you choose to solve for first. So if I just choose the x, we're then going to basically say x squared equals the other two sides, so 7 squared plus 10 squared minus 2, multiplying with the 7 and the 10, the 2 I just used, and then the cosine of the 36 degrees. So to solve this, 49 plus 100 minus 140 with the cosine of 36. And then again, you can do all this on your calculator. I'm just trying to work here by hand. 149 minus 140, cosine of 36. Now I've reached a point where I can't, so I have to do cosine of 36 on my calculator and get a decimal, multiplied by 140, subtract that from 149, and then square root that answer so that you get what x is. And that should be 5.98. Now, I have an opposite set. I can shift gears to law of sines, and I can say 5.98 over the sine of 36 equals, and let's solve for the m, 7 over sine of m. So on my calculator, sine of 36 times 7 divided by 5.98, inverse shift, however you do it, to get it to spit out the degree with sine, and it should tell you that m is 43.47 degrees or something fairly close to that. Once I know the m, I can then do 36 plus that taken from 180 to get y, and I've solved for all of the parts, and that would be 100.61 degrees. So even if I have to start with law of cosines, I can use other methods to end up solving for the other missing pieces. Example 2, solve the triangle for its unknown parts. Y, 7, 5, 8, x, and z. So again, I do not have an opposite set, so we're going to do law of cosines. Doesn't matter which one I start with, so let's do 7 squared equals the other two sides, 5 squared plus 8 squared, minus 2 times the 5 and the 8, the 2 I just used, cosine of, we did the 7, so x. And now to solve, 7 times 7, wait a minute. No, hang on. Ooh, that didn't feel right. 49, 25, and 64, then minus 10, 80, cosine of x. 49 equals 64 plus 25, 89 minus 80 cosine of x. So we're going to minus 89, should be negative 40, equals negative 80 cosine of x. Divide by the negative 80 to remove it. Negative 40 divided by negative 80 turns it into positive 1/2 or 0.5 is your cosine of x. Again, you want the calculator to spit out degree, so you're going to second or inverse your 0.5 with your shift cosine, second cosine, inverse cosine, and it is spitting out x is 60 degrees. Now I look here and it appears that this is acute, so it should be 60 degrees. They give you the other value, but since this is acute, I don't need to stop and figure it out. Now that I have an opposite set, I can shift to law of sines. So we're going to do 7 over sine of 60 equals 5 over sine of z and 8 over sine of y. Well, I should box that. And then on the calculator, sine of 60 times 5 divided by 7, shift second or inverse sine, and you should get that z is 38.23. And you can either do the other law of sine, or you can say 60 plus 38.23 subtracted from 180. But however you're doing it, the y should come out fairly close to 81.77 degrees. Example 3. They give us 28 degrees B, M, and that one's definitely obtuse, 14, 10, and K. So again, we don't have an opposite set. Let's do K. K squared equals 10 squared plus 14 squared minus 2 times 10 times 14. Cosine of the opposite is 28 degrees. So on the calculator, I would do cosine of 28 times 14 times 10 times 2, and then do 100 plus whatever 14 squared is, subtract those two, and you're getting down to k squared equals whatever that number is, and then square root it to get what k is alone. So 6.98 or something approximate. Now I know an opposite set, so I can do 6.98 over the sine of 28 equals 10 over the sine of b, and sine of 28 times 10 divided by 6.98, second shift or inverse sine, and you should get that b is, I'm looking for their number here, 42.2 degrees. That is acute. That matches with the picture. And then I can do the 28 plus the 42.2 subtracted from 180 and get that the m is obtuse. And so it should be coming out 109.8 degrees. I could have done another law of sines to have accomplished it. I'm just trying to give you the quickest and fastest way to accomplish all of these examples. All right, example 4 is more of an application problem. They give us a figure where I've got a post, you've got some ground connecting down to the ground from here and here to the same spot. That was a little crooked. All right, this is 50 feet. This is an L. Obtuse is the B. 15 degrees written way down here, and then 150 feet for that side. Again, do I have an opposite? Oh, what's it want? The figure shows two cables that are attached to a vertical tower from a point on the ground. The angle between the cables is 15 degrees. The longer cable is 150 feet long, and it's attached to the top of the tower. The shorter cable is attached 50 feet below the top of the tower. Find the length of the shorter cable. So L is what we're looking for to solve. So I do not know the degree that is opposite the L, but I do have that 50 is opposite the 15, so I can do a law of sines. So that would give me 50 over sine of 15 equals, and now do I have enough? Well, I can find the B, and then by default I can get to the other. So 150 over sine of B. Then let's see, sine of 15 times 150 divided by 50, second shifter inverse sine, and B spits out 50.94. Now, that's acute. This is obtuse. So I have to stop and figure 180 minus 50.94 to get it into the obtuse format that it should be. So B should actually be 129.06 degrees. Now that I know that, I can do 15 plus 129.06 taken away from 180 and get that the top angle should be they're saying L, oh, they're saying L was a degree. Never mind. 35.94 degrees. Despite how they're labeling it. And then I can do the 50 over sine of 15 equals the L that I labeled L with the sine of 35.94 being its opposite. So sine of 35.94 times 50 divided by sine of 15 should give me that L is 113. Oh, I guess they were doing a little l and a capital L. Yeah, because they were matching up the sets, of course. And then because this one was labeled in feet, I know that the length of the one I solved for should also be labeled in feet.